In the name of God. Hello, dear students. My name is Masood. I'm a physics teacher. We are at Fairhoz website at your service. We have an application. You can download it on, let's say, on Play Store of your cell phone. If you want to have these videos, actually, we are going to, let's say, to present the whole curriculum of the grade 10, actually. And in previous lectures, we finished chapter 1, and we solved some questions from chapter review. Right now, I want to, let's say, move on to the new question. The question is question 29. Let's get started, right? Question 20. Let me read the question for you. Estimate the number of breaths taken by a person during 70 years, the whole, let's say, life of a person, the average lifespan of a person. This is the average lifespan of a person, 70 years old, actually. We want to estimate the number of breaths, actually, for this person. Firstly, estimate one breath every 5 seconds, right? Every 5 seconds, actually, you have one breath. Number of breaths, actually. You have to write, you have to, let's say, convert 70 years to what? 70 years to the second. So how many days are there in 1 year? 365 days, right? This is the number of days. Let me explain. This is the number of days. So how many hours are there in one day? 24 hours, right? How many minutes are there in 1 hour? This is minutes, 60 minutes. How many seconds are there in 1 minute? That's why you have to do this, let's say, operation. And by the way, 70 means this is the number of years, right? The lifespan of a person. Why do you divide it by 5? We assume that any person, actually, in 5 seconds, it has only one breath in 5 seconds. That's why you have to multiply these numbers divided by the, let's say, average number of breath, excuse me, average number of breaths of a human. So you have to convert the lifespan to the second divided by 5. And you get this number. So 4 times 10 to the power 8 breaths. This is the number of breaths that the person take in, or let's say have it in during its lifespan. Let's move on to question 30. Question 30, let me read it for you. Estimate, question 30, estimate the number of times your heart actually beats in an average day, number of, let's say, beats of a person, and number of, let's say, heartbeat of a person in every, let's say, in each day. So estimate one heart breath per second, right? In 1 second, we have, let's say, one heartbeat, right? Whenever you count the number, for example, 1, 2, 3, 4, by, let's say, by each second, your heart, let's say, I can say beats, right? So I can say the number of heartbeat is, let's say, coincide with your counting, with the number of seconds, actually, right? How does a second hand of a clock actually, let's say, move? In each second, it moves a certain distance. So this is the number of, let's say, heartbeat. The number of heartbeat, it's like this, right? In each second, we have one heartbeat. Number of heartbeats, 24 what? Actually, how many hours are there in one day? 24 hours. We have 24 hours. This is the number of hours, right? How many minutes are there in 1 hour? 60. This is the number of minutes. How many seconds are there in 1 minute? Actually, 60. You have to multiply these numbers, and this is the answer of the question. Question 31, estimate the magnitude of your age. Your age, actually. It's optional. Maybe you are 15 years old. If you are a student of grade 10, maybe you are 30 years old if you are a teacher, or maybe any, let's say, person that watches, let's say, this video. This person can, let's say, put his or her, let's say, age here to find the answers. It says, estimate the magnitude of your age as measured in units of second. You have to convert your age into the second, right? Assume that a student is 15 years old, for example, right? 15 years old. 15, this is the number of years. How many, let's say, days are there in 1 year? 365 days. How many hours are there in 1 day? 24 hours. How many seconds are there in 1 hour? Actually, 3,600 or 3,600. If you multiply these numbers, you can get the answer. So this is the age of a person in second, not in year. In year is 15 years old. 15 years old is equivalent to 5 times 10 to the power 8 second. They are correspond to one another, right? Let me solve another question for you. Question 20, question 32. Question 32, let me read the question for you. An automobile tire is rated to last actually for 100,000 kilometers. Estimate the number of revolutions the tire will make in its lifetime if its diameter is 0.3 meters, right? So how can we solve this problem? We have an automobile. The automobile actually has a tire. This tire actually, let's say, revolves, yeah? Revolves. It says, what's the question? Estimate the number of revolutions. What do we look for? We look for the number of revolutions. We have to find the number of revolutions. Right? We have to find the number of revolutions like this. How to, let's say, calculate the number of revolutions for a tire, actually automobile tire. Firstly, you have to, let's say, find the radius of a tire, because we have a diameter of a tire. This is the diameter of a tire. Diameter means from edge to edge. This is diameter of a tire. This is D. But we need R, actually. We have to divide it by 2. The answer will be 0.15 meters, right? This is the radius. After that, the distance that is traveled by the automobile, the question gave it this information to us, actually, gave this information, 10 to the power 5 kilometers, right? This is the distance that is traveled by the car tire, right? But you have to convert it to meters, because you have to unify the units, right? You cannot, let's say, use, for example, radius in meters and distance in kilometers. You have to unify the units. What do I mean by unify? You have to convert kilometers to meters. How do you convert kilometers to meters? Kilo means 10 to the power 3. That's why you have to write the value of kilo. And we have 10 to the power 5, means 100,000. Right now, we have, let's say, one common base. You have to write one of them. And after that, you have to add the exponents together. So we have 10 to the power 8 meters, right? We have a circumference of 1. We have a circumference of a tire, right? You have to find the circumference, right, of a tire. Means this circumference means this one. Let me try it by another color. Circumference means surrounding of a tire, surrounding, outer part of the tire. This is circumference, right? So C is equal to 2 pi r. I want you to memorize this one, because tire is circle. This is the rule of circumference of a tire or any circle. C is equal to multiply by 3.14 because pi is, let's say, constant ratio, 3.14. And R, we already found 0.15 meters. This is the radius of a car tire. And this is the circumference of a car tire, right? So how do we calculate the number of revolutions? By dividing, right? By dividing the entire distance that is traveled by the car by what? By the circumference of the car. So this is the rule, right? Number of revolutions. If I write number of revolutions, nicer actually. Number of revolutions is equal to what? 10 to the power, it means what? It means the total distance, right? The total distance traveled by each tire. Divided by circumference. Circumference of a tire. Circumference. That's why the answer 10 to the power 8 divided by 0.94. The answer is 10 to the power 8 revolutions, right? Let's move on to another question. Question 33. Imagine that you are, let's say, you are equipment manager of a professional baseball team. One of your jobs is to keep a supply of baseballs for games in your home. Let's say ball pack, right? Balls are sometimes lost. Sometimes you lose the, let's say, ball, right? When players hit them into the stands as either home runs or, let's say, foul balls. Estimate how many baseballs you have to buy per season. How many, let's say, baseballs you have to buy per season, right? In order to compensate the, let's say, lost baseballs. You lost some baseballs actually. You have to compensate it. How do you compensate it? By buying a new baseballs, right? Let me read the entire of the rest of the question. It says, this is the actually question. Focus on this part actually. It says, estimate how many baseballs you have to buy. So what do we look for? We look for the number of baseballs, right? You have to buy per season in order to what? In order to make up for such loss, let's say loss actually. Make up means compensate in order to keep the number of baseballs constant. Whenever you, let's say, lose a ball, right? You have to compensate it by what? You have to make it up by buying a new ball. That's why we look for the number of baseball, right? But here we have, let's say, hint here inside the bracket. It says, assume your team plays an 18 game home schedule in a season. 18 game, number of games actually that is taking place by the team is 18, right? Assume an average loss of 5 balls in each, let's say, in each match. It's very easy. Just multiply the number of balls by the number of games, and you can get the answer like this. So number of purchased ball is equal to 18. Multiplied by 5 becomes 90 balls. You have to, let's say, buy 90, let's say, new balls. That's why, in order to make the, let's say, loss, you have to buy 90 balls. Let's move on to another question. Question 34. A chain of hamburger restaurants actually advertised that it has sold more than 50 billion hamburgers over the years. So they estimate that this, for example, restaurant, they estimate that they sold 50 billion hamburgers let's say, till now, over the year actually, over the years that they opened the restaurant, actually, they sold 50 billion hamburgers. Estimate how many kilograms of hamburgers. So what do we look for? We look for the number of kilograms. How many kilograms of hamburger meat must have been used by the restaurant chain to make 50 billion hamburgers, right? So we look for, let's say, how many kilograms of the meat actually that is used by, let's say, a restaurant, and how many head of cattle. How many head of cattle? How many cattle? Let's say head of cattle means how many, let's say, cattle. How many head of cattle were required to finish the meat for these, let's say, hamburgers? So we look for two things. Firstly, we want to, let's say, find the number of, let's say, we have to find the, let's say, number of kilograms, number of kilograms that is used by the restaurant, or we look for the, let's say, mass of a meat that is used by the restaurant. After that, let's say we look for the number of cattle, number of head of cattle. Let's say they sacrifice, actually, they served it for their customers. Firstly, this is, for example, we have an assumption here. We have an assumption here. This is our assumption. Estimate 1/10 kilogram per hamburger. For example, you have to, let's say, estimate the mass of each hamburger. We say that each hamburger contains 1/10 kilogram, means 0.1 kilogram, approximately 100 grams, 100. And mass is equal to, M is equal to 5. This is the number of what? This is the number of, actually, hamburgers that, let's say, that have sold actually in advance or before. 5 times 10 to the power 10 multiplied by 1/10 kilogram. So this is the number of sandwiches, let's say, number of hamburgers multiplied by the mass of each hamburger. You can find the answer, and the answer will be 5 times 10 to the power 9, because 10 simplifies with one's exponent, and the answer will be 5 times 10 to the power 9 kilogram. This is the first one. What do you say about other one? We want to look for the number of cattle, right? That, let's say, that served during these years, actually. Estimate 400 kilogram per head of cattle. For example, maybe the number is a little bit far from the reality. It's not very, it doesn't coincide with reality, or I can say it doesn't make sense, actually, 400 kilogram per head of cattle. But I use this number in order to, let's say, coincide the answers of my fascicle with the answer of teacher's book. That's why I used 400 kilogram. So estimate 400 kilogram per head of a cattle. Assume that the mass of one cattle is 400 kilogram, right? So number of head means number of cattle, right? Number of head is equal to what? 5 times 10 to the power 9. We found it, actually, already. This is the mass of entire sandwiches or hamburgers that sold during these years. 5 times 10 to the power 9 divided by 400 kilogram. So this is the mass of one, let's say, head of cattle. The entire mass of sandwiches divided by the, let's say, mass of each cattle, you get this number. So this is the number 1.25 times 10 to the power 7 head of cattle. So they sacrificed how many, let's say, head of cattle, actually, how many head of cattle I can say, let me write it for you, 1 to 5, 2 decimal places, we'll go with 2, let's say, powers. Here we have 5 zeros here after the 5. Let me read the number for you. So 12,500,000 head of cattle were sacrificed during these, let's say, years, right? Let's move on to another question. Question 35. Question 35. Estimate the number of table tennis balls. So we look for the number of table tennis balls that would fit without being crushed, actually, into a room that is 4 meters long, actually. 4 meters wide, this is the dimension of the room. Length, width, and height, actually. 3 meters height. Assume that the diameter of each ball is 3.8 centimeters, right? So right now, you have to think about the table tennis ball, actually. Table tennis ball is a, we have a, let's say, table tennis ball is a circle, yeah? Approximate, it's a sphere, actually. It's a sphere. It's not perfect circle, it's a sphere, right? Firstly, you have to find the, let's say, radius of a table tennis. R is equal to D over 2, because we have a diameter. It gave, the question gave this, the diameter of the table tennis ball to us. So that's why you have to divide this number by 2. After that, centimeter is not allowed in SI. You have to convert it to meters. How do you convert centimeter to meter? I told you, from the smaller one to the larger one, you have to write the negative exponents. That's why 1.9 times 10 to the power negative 2 meters. This is the, let's say, this is the radius of a table tennis ball in meters, right? So volume of the room, you have to find the volume of the room. Is information available for finding the volume of the room? Yes, of course, because we have, let's say, length, width, and height. Just multiply them together to find the volume of the room. So what other information, let's say, do we need, actually? You have to find the volume of the ball. Volume of each, let's say, sphere, yeah? So volume of a sphere, you have to memorize it, 4 over 3 pi r cubed. This is the volume of the, let's say, of a sphere. Volume of each table tennis ball. 4 over 3 becomes 1.33. Pi is a fixed number, 3.14. R, we calculated R, actually, already. We divide the diameter. You know this one, actually, on put these numbers here, and this is the answer, actually. 4 over 3, I told you, it will be 1.33. Pi 3.14, and r cubed. You have to, let's say, cube the, you have to cube the r, radius 1.9 times 10 to the power negative 2. Right now, you have to cube the entire bracket, and the answer 1.9 times 10 to the power negative 2 cube. The answer, the entire answer, or the last answer, this number is the last answer. So right now we have two, let's say, volumes, right? Right now we have two volumes, volume of a room and volume of what? And volume of each table tennis ball. Whenever you divide the entire volume of a room by the volume of each table tennis ball, you can guess the number of table tennis ball that fit the room approximately. Actually, this is rough estimation. It's not very accurate. It's the rough estimation, let's say, right? Number of balls, volume of the room divided by volume of each ball. Volume of the room, 48, divided by this number. Actually, this is the number of balls that could fit the room, because it says estimate the number of table tennis balls that would fit without crushing, actually, into a room. So this is the process actually. You have to find the volume of the room. After that, find the volume of the, let's say, table tennis ball, which is a sphere, right? By the way, each volume, for example, volume of the room, has its own rule. It's a systematic, actually, technique. You have to obey the rule. You have to apply this rule. And the volume of the sphere or volume of the, let's say, ball is 4/3 pi r cube. All right. After that, you divide the volume of the larger volume. Let's say you divide the larger volume, which is the volume of the room, by the smaller volume, which is the volume of the sphere. Right. Let's move on to the other question. Question 36. Question 30. Calculate the circumference and area for the following circles. Circumference and area for the following. So use the following formulas. It gave us some formulas actually. This is the rule of circumference. Rule of circumference of a sphere, C is equal to pi r, and rule of area is equal to pi r squared, right? Circle of radius 3.5 centimeter. Only by one information we have to find we can find the circumference and, let's say, area, because we need what? We need radius, right? You see? Because pi is constant and this too is constant. That's why by only one information, which is radius, actually by only knowing the radius, you can find circumference and area. C is equal to pi r. By the way, it doesn't need to convert it because let's say here only we have, it doesn't mention it actually. The question doesn't mention it, let's say circumference or for example area in meters or in any other units. It says find the circumference and area. So it's optional, it doesn't matter whether you convert it or not, but we don't convert it because we don't have any hint or tip here. That's why bring it down and put it, substitute it as it is without conversion. 2 pi r, this is the rule of circumference. 2 multiplied by 3.14 multiplied by 3.5. This is the answer, 22 centimeter. And you know what circumference is? Circumference means the surrounding of a circle, surrounding. The outer part of the circle is circumference, right? Outer part. What do you say about the, let's say, area, pi r squared? This is the rule of area of a circle, pi r squared. Area is equal to pi. I told you, pi is a constant number. 3.14 multiplied by r, 3.5 squared. The answer is 38 centimeters squared. Be aware, use centimeters squared. Don't, let's say, use meters squared here because you didn't convert it, right? Some students, let's say, get used to write meter, actually, meter square or meter. But here, we didn't, let's say, convert the unit. Let's say we use the original unit of the question without conversion. That's why the answer is taken, or we get the answer is in centimeters square, right? So what's area of a circle? Area means the inner part of the circle. This part is area. So the outer part is circumference, right? But the inner part is area, right? This part is area, the inner part is area, but the outer part is circumference. And by the way, circumference is measured in centimeter, area is measured in meter square or centimeter square, right? So the unit of the circumference is just centimeter, not centimeter square. But unit of area or area of anything, actually, unit of area of anything, it's not just for circle, even area of this room or area of any, let's say, any object is measured in squares, yeah? The unit of length square. whether the unit is centimeter, meter, it doesn't matter, right? So I didn't solve B actually. I left it actually for you. Let's say you can just substitute it here. A circle of radius 4.65 centimeter. Just substitute this number here. So C is equal to 2 pi. 2 means pi means 3.14 multiplied by what? By this number 4.65. You can find the answer, and the answer is measured in centimeter, not any other units. What do you say about this one? A is equal to pi r squared. I can write A is equal to pi 3.14 multiplied by this number, radius, right? 4.65 square. And the answer is anything, actually, whatever number you get. You square this number, you multiply by 3.14, and the answer, whatever number I told you, what do you get actually after the number? You have to write the unit, which is centimeter square, right? So guys, that's all for today. I hope you enjoyed this lecture. I'll see you in the next videos, and bye for now.